Buenas tardes. Ahora tendremos nuestra siguiente conferencia magistral a cargo del señor Justin Choy de SAS. Está siendo moderado por Alfredo Bustos. Esta conferencia se impartirá en inglés. Aquellos que necesiten traducción, por favor, a la entrada hay algunos audífonos. Gracias.
Vamos a dar un par de minutos para que quienes salieron por sus audífonos para la traducción se reincorporen ahora. De cualquier modo, si me permiten, puedo ir adelantando con la presentación de nuestro orador en este momento. Por cierto, el programa decía que esta sesión la moderaría Enrique de Alba. Ya se habrán dado cuenta que no soy Enrique de Alba. ¿Qué tal, Enrique? ¿No? No, el programa decía, pero que bueno, ya se dieron cuenta. En fin, permítanme leer una breve semblanza de Justin Choy y su paso por SAS en particular. Justin es gerente de producto en una doble capacidad. Por un lado, en la nueva suite Visual Analytics de SAS, tanto en el Hub y en el Explorer, así como en el dashboard de SAS en Business Intelligence de la nueva suite de software de SAS Enterprise Business. Es responsable de reunir los comentarios y sugerencias de los clientes para el software de SAS, creando así requerimientos y dando prioridad a la investigación y el desarrollo de SAS para producir soluciones de software de vanguardia. Justin cuenta con más de 15 años de experiencia en la industria de la tecnología, que abarcan la programación, el soporte a clientes, la capacitación y la educación, la consultoría, el soporte de ventas, la implementación en campo y el desarrollo de producto en todo el mundo. Recientemente, Justin supervisó la implementación global en campo del personal de soporte de ventas para el software SAS Business Intelligence, incluyendo el soporte de ventas para contratos de inteligencia de negocios a escala global y el apoyo al crecimiento de los ingresos de este software. Antes de integrarse a SAS, Justin trabajó en el Departamento de Tecnologías de Información de Park Hyatt en Sydney, en Australia, y en IBM también en Australia. Justin se unió a SAS en 1997 en la oficina de Sydney en el primer programa de graduados. En 2000 fue transferido a las oficinas corporativas para apoyar a los clientes de SAS en todo el mundo. En 2005, Justin cambió sus responsabilidades a la implementación en campo y soporte de ventas para América del software de SAS Business Intelligence. Ayudó a SAS a hacer crecer su software de inteligencia de negocio y en 2007 se le pidió hacer esto a escala global y continuar habilitando al personal de SAS e impulsar el crecimiento de las ventas de software de SAS Business Intelligence. En 2010, Justin asumió su actual puesto en la administración de productos. That's more or less a brief summary of what Justin has been doing with SAS. So, without further ado, you have the floor.
Thank you, Alfredo. Forgive me for my Spanish isn't that good, but muchas gracias for having me come down and present for you guys. For the last 2 years, SAS has enabled me to travel around the world to talk about big data and about high performance analytics. So I've been in Sydney, Australia, I've been in New Zealand, I've been in Asia, I've been in many countries in Europe talking about how SAS is dealing with big data as well as high performance analytics. From my background, it comes from a business intelligence standpoint. And as you know, business intelligence covers a wide variety of areas. It includes analytics and it includes the data acquisition piece. In the last few years, just about every conference that you go to in computing, in software, everyone talks about big data. And there's many different definitions of big data out there. What does big data mean to you? It means a lot of different things to different people. Take, for example, if we look at a telecommunications company that does cell phones. Those guys, big data for them is all the call records from your mobile phone that come in every day and they want to look at that transaction. That's a lot of data just there. If you take your small shop along the side that is selling a few things and they're doing a small spreadsheets looking at their profit and loss and their how profitable they are, big data for them may be 10 megabytes. So The definition that SAS likes to use, or what we like to say, is big data is the amount of data or complexity of the data that becomes a concern to you because you can't do your analysis at a speedily time. You can't query that data. There's just so much of it that you just don't know what to do with it. That becomes a big data problem out there. So if you were to talk to people like Oracle, DB2, the big major database vendors, they'll tell you big data is unstructured data. Unstructured data being things like Twitter streams, social media data, anything, lots of text where you can't put ones and zeros against. Again, another definition out there, but at the end of the day, big data is a lot of things. Just a quick quote that I saw from Gartner just produced actually yesterday. They surveyed 720 companies. Out of those 720, 64% said that they were looking at big data projects this year if they hadn't already. 20% of those are piloting or experimenting on big data. So that means they're looking at big data technologies, they're looking at things like Hadoop, big data stores, they're looking at figuring out what a strategy is going on. The guys, the 18% deploying a strategy, I don't know how many times I've been called into, at SAS, we have a briefing center and we have about somewhere between 5 to 6 customers come in every day. We have briefings with our customers and potential customers coming in asking us about big data and what they should be doing. So it's at pretty much the foremost, a lot of people thinking about what should I be doing with big data? Is this a concern to me? The other 19% are just knowledge gathering. So they're going to conferences and they're turning up and they're hearing, hey, big data, I've got to do something about it. I need to figure out what it is. Do I need to buy hardware? What do I need to do? So, and then the rest of them have no plan or they don't know what to do. So, but this is changing because big data is out there. It's happening and you need to know what to do with it. And this is what this presentation is about. So big data, as I said, comes in all different sizes. We just put a lot of different people up here on this slide to say, hey, there's a lot of things like databases, major database vendors there. SAS is in big data. We have the elephant, the yellow elephant being Hadoop is out there. We have the little utilities on the right-hand side underneath Teradata. So utilities, when you are doing anything monitoring electricity supply, you have a lot of sensors. Sensors throw out a ton of data every second. That's big data. If you think about these guys, they're dealing with petabytes of data, of information every day. They need to figure out what to do with it. How can I effectively charge or make sure my electricity demand meets the demand out there? How do I charge for it? Can I reduce costs for people? Can I increase costs? How do I make sure that my peak electricity demands meet? All these things become big data. Point of purchase sales. Think about Amazon, one of the major big web retailers out there. They have their organization spread across the world. They've put distribution centers in multiple cities such that you can get, when you order online, you can get your product within 3 to 5 days. They have a big data problem because they've got millions of people making transactions every second. Not even going even further, the major credit card companies go through this company called First Data. They actually process every single credit card transaction in the world. Imagine them trying to figure out whether or not someone's using your credit card fraudulently. Like today, I'm getting all these emails saying, hey, you're using your credit card in Mexico. Is this a fraudulent transaction? This is happening within about 1 minute of me making a transaction. I'm getting an email back. Imagine how much data these guys have to go through. To them, that's big data. So big data to you guys can mean a lot of things. Demographic data. It could even mean augmenting your existing data with demographic data, geographic data, which is expanding that in such a wide amount that you can no longer process that in an effective manner. So what's the challenge here? Big data. Everyone, if you didn't know already, big data, most people talk about big data being volume, size, variety, the type, structured versus unstructured. So we're talking about relational tables, OLAP cubes, etc. That's structured data. Unstructured data is free-form text in a Word document, PDF. So take, for example, if you are familiar with the website Travelocity. Travelocity allows you to go on and do lots of reviews about hotels and other places. If you're a hotel company and you want to analyze whether or not people are saying good things or bad things about your company, you have to parse all these threads. Same with Twitter. That's unstructured data. It's all text, not ones and zeros. You've got to figure out what to make out of that. That's the variety. Velocity, that's the speed at which you can get to that data. At some point, you're going to be querying such a large amount of data that's going to take you a long time to get back. Added on top of that, when you run analytics on that, it takes a lot of time there. Most of the time, most analytics people, when they're dealing with modeling, statistical modeling, for example, are using about 1 million rows of data, give or take 1 to 10 million rows of data, sampling, and then making a model, running it against the information, and then seeing if there's a champion challenger model from there. That takes time, and we'll talk about how SAS is changing that to make it a whole lot different. Where SAS believes big data brings value to the equation, so we like to say big data is made of 4 things, not just the volume, the variety, the velocity, but how do you get value out of that? If you know what your relevant data is, that means that, for example, if you're Amazon, you know if your sales are up, you know if your sales are down. How do you then find out whether or not a specific product line has a good reputation or not? Sure, you can look at the ratings, but maybe the ratings don't tell you the exact information. Reviews will tell you one thing, but maybe you need to augment that out with social media sites like Twitter, that people tweet about things. Take the UN, for example. They have predicted that in a country, actually in Indonesia, when they actually have Ramadan, a lot of people are worried about the food supply because the last few years they've had a shortage of actually wheat for them. So what they have noticed is that social media is actually able to predict whether or not the food supply is going to be adequate enough during that time of Ramadan, because of course they can only eat during certain times. And so in 2008, they weren't able to actively predict how much food and how much resources they will needed to supply at that time. In 2011 and 2012, social media actually outpredicts the best statistical engine out there in terms of what food and supply is. So this is the UN looking at a lot of data and using that to be able to do accurate predictions, and that's a lot of data for them. So how do you know the difference between the relevant data, the big data, and information overload? And that's where statistics comes into play here. So a lot of the people out there know that from a BI standpoint anyway, people like to look at reports, they like to look at alerts, they like to look at drill down reports about historical data. But we like to call that reactive analytics. If I'm just running my standard descriptive information, I can just see what's happened, but I can't tell you what potentially could happen and what can you do to change that area. We like to say a lot of people like to deal with the reactive analytics, and that's your regular BI. When you come into visualization and more of the advanced high performance analytics that SAS is trying to do, we like to sit, and most of you guys know, we live in the optimization, the predictive modeling world, the forecasting, the heavy duty statistical analysis world. So we want to take that existing data that you have, we want to bring value to that, we want to tell you, hey, your sales are down and this is why sales is down. This is why someone is going to a particular area. If a flu outbreak happens in a specific area, can we actually track that? Can we actually help you get resources to the right hospitals such that you can deal with the number of people coming in and managing that flu outbreak? This is what proactive analytics is. I'm sure you guys know this already, so it's a little bit of a rehash, but I'm just going to go through and jump out. Again, we like to show statistics here, but this screen here shows you that in the last, even in my area that I look after, the business intelligence area, the demand for predictive analytics, we spoke about this in probably around 2006. From a company standpoint, we'd like to try and tell everyone, hey, you need predictive analytics, you need to get there. But people were like, hey, we just want the reactive analytics, we just need to know what's going on. In that space of 6 years, times have changed now. Just about everyone is looking at some form of predictive or some type of analytics to help out in their area. So the predictive analytics area has surged. We have both retrospective, looking backwards, and equally people are looking into that. So it's top of mind. If I look at the CEO reports, specifically around IT, a lot of IT vendors say, hey, we need to get some predictive analytics into our companies. Can you help us? So how does SAS describe the whole big data challenge with high performance analytics? We like to use a metaphor called the SAS analytical life cycle, and this is just describing the process in which you take your data, you get the value out, how you put it into a process such that you can reuse it and then evaluate it. So simply, and I'll take 2 seconds just to go through this. When you have a lot of data, you need to actually get the data in a form that you can understand it. That's the data prep side. You then need to, as part of that data preparation, you may be doing some exploratory analysis just to understand the data. Once you understand the data, and this could be your IT guys, your data scientists, your business analysts, once you start understanding the data, then you want to start modeling that data. When you finish modeling the data, you then want to put it into actual production. So not just that, so once you've found out what you need to do, you want to put it in a process such that all new data gets scored and is available for that. That requires IT process. Once you've done those models and got your information out, you need to evaluate whether or not that model is giving you the right results. And so that's the evaluate piece. And then you want to, and we have this, what we like to call a continuous circle, but it doesn't have to be. At that point, it's not like that you stop, but you can also build a challenger model or other models to test to see if the actual current model set is giving you the correct lift, if that's what you're after for marketing from there. So the analytical life cycle that we like to say can be broken down into different areas of what you're looking at. A lot of people, for the big data challenge anyway, are starting at the data prep side. Hey, how do I just get all this data together? I've got data from multiple databases. I've got this unstructured data. How do I get it together? And then how do I start exploring that and building models of that so I can tell more information from there? And I can give you an example around data there. So we just have in here where the different personas of people come in. Data prep is usually owned by either the data scientist or the IT staff, your business analysts, the people exploring your data. The statisticians are the ones who are actually starting to build the more complicated models. And then the IT staff manage deploying those models into production such that they're scored. And then your managers or other business analysts will evaluate whether or not the results are correct and then move on. So if we look at big data along this interesting different axis, and if I look across, we're talking about from the left-hand side, the question of, we can ask questions of what do we know from the left, or I just thought there was a screen behind me, to the right, what questions don't we know, and then from top down, what we already know about the data versus the unknown data that we have. So if I use the example of Amazon, if Amazon comes in and says sales are down, how do I get that information? Today we go to an EDW and we apply some generalized business intelligence off that, and we can generate some reports. So big data plays a role here because you could be hitting multiple operational systems trying to pull that information out, getting into one location such that you can actually report the same value all the time. Then you might want to ask the question, so we know the data is already there, why is that happening? How do we do that? Well, we can do some new forms of data visualization. There, as you may or may not know, exploratory analysis using some basic statistics is a lot of BI companies are moving into this area now, helping customers figure out why did things happen. So these are getting to the questions, hey, we don't know what's happening, what are we doing? And this is getting into exploring more of that data. So they're getting into the side of, hey, there's a lot of data out there. I've got a lot of different transactional systems with data. I may have Excel spreadsheets. How do I get all that information together in one place so that I can actually explore and figure out what's happening? If we move up to the top, what's the cause? We start having to blend things like, as I said, if we use the Twitter as an example, and I'll use a different one. If you remember a couple of years ago in London, they had a bunch of riots out there. People were very upset. They got together and they started congregating and starting fights and burning down places. Well, the London Police Department or the government got together with them and they realized that if they actually tracked social media, they could actually see when people started tweeting and when they started congregating and what was happening. And so based off those riots, they are now looking at social media and augmenting that data and figuring out if a flash mob, if you know what those things are, when people get together and do dances on stage in front of a wide variety of audiences, if there are mass gatherings of people, they can quickly and effectively deploy more police out there such that people think the audience is in control. Before the actual riots, they were just looking at data saying, hey, you know what? I need to allocate 2 policemen or 3 policemen in this area because there's a population of X there. And in the next suburb or next area, they allocated 5 or 6 policemen because they had more people. So they were just pushing people around in different areas without knowing where the people actually were. By augmenting their existing data with social media data, they were able to effectively allocate people to the right areas when needed and move them around. Another example of this same type of thing is in the Americas. There's certain cities in America that are slightly worse than others in terms of crime, and that some of the actual local police departments are actually going out and using social media and figuring out where people are congregating, and they're sending their police forces into areas where people are saying, hey, this is a bad area, we need to clean it up. They just send a cruiser, a policeman or policewoman, through that area every 30 minutes, and it's having a major effect because the crime in those areas are going down. So just by understanding and knowing where things are happening, and social media is just one example of unstructured data, but knowing that, they're able to say, hey, what's happening, where's it happening, and how should they adjust to it? So the last one, again, is just using that Hadoop, and we'll talk a little bit about this a little bit later on, and with the technology here, how technology can help you solve your big data. But the Hadoop and predictive analytics here helps you figure out where you should be allocating your people, how you should be allocating them the most effectively, for example. We have a bunch of other examples here, and then we're just going to put in the other people who are usually responsible for these areas. So generally in BI, it's your managers, your business intelligence, your frontline people that do that. Your business analysts are the ones starting to look at answering the questions why. Your data scientists are doing a little bit of that discovery, and your statisticians are helping tell you what you should adjust, what you should change in your business practices from there. So as I move through these slides, I have a couple. So I thought about putting just a quick technology checklist to talk to you about, hey, you know you've got a ton of data, you know that you can't get to it very fast, or your statistical processes are taking a long time. What are some things that you can do to alleviate those problems? The first one is the flexible data architecture here. The big elephant or Hadoop comes into play a lot, and the main reason that is because in the past few years, databases have been used predominantly for a lot of storage, and with that storage, the price of disk has dropped. Now, the problem with big data is when you're starting to look at a lot of sensor data, a lot of unstructured data, it's harder to compress that information down. You can compress ones and zeros, but it's hard to compress your text. So that in the last few years, you may have heard these new databases called columnar databases have come up, where they've actually switched the rows to the columns and the columns to the rows to try and effectively compress the data there. What these vendors like Hadoop and a lot of the other actual big database vendors have invested in now is using lots of computers together to store all this data. Amazon, Facebook, all these guys have thousands of computers all running parallel together, utilizing things like Hadoop to store the data and be able to access out and ask questions from it. So they're using, on the left-hand side, this grid computing. Added with grid computing, they use in-memory technologies, because of course, when you write to disk, disk is slow. When you keep having to access disk, it takes time. The fastest thing is to throw it up into memory, you can get it really quickly. The other movement was, as data grew, people didn't like the movement of data. I have 4 databases, DB2, I have Oracle, I have MSQL Server, whatever you want to name out there. I have Excel spreadsheets. How do I get all my different data from all the different systems from whoever you do business with or talk to? How do you get all that into one location such that you can store it all? It becomes difficult, and a lot of the database vendors, their machinery was extremely expensive when you added on racks and racks. That's where Hadoop came into play. They started to use commodity hardware, they used cheap PC disks, they used a lot of them, they built in algorithms to handle redundancy, where they store one bit of the data on one computer, they store another bit on another computer, and just for extra redundancy, they store another bit on a whole nother rack or blade of computers, such that if one of those nodes ever goes down, you can query it smart enough to know to get the data from 2 other sources, and then you can change the redundancy from that. So the in-database world was to say, hey, instead of moving all the data, how can we assist you by doing the analysis inside the database? How do we stop the movement of the data? How can we do that approach? And then the advent of the enterprise data warehouse, not sure if you guys have one of those implemented or people are implementing these. This was a good place to try and grab all your data together and put it in third normal form where you had no redundancies, but the problem was your end users and your statisticians couldn't use that data, because when you do statistical analysis, most of the time you need very wide rows and you need them repeated, and third normal form doesn't do that. So you started joining lots of tables, making these wide columns, lots of them, and guess what? Most of the databases hit a limit of 1,000 columns, 2,000 columns. You got stuck, you couldn't do it anymore. That's why these alternate big data repository stores came out. They don't have limits on the columns that they can store. They can store thousands of columns, so you can do analysis across thousands of different attributes without a problem, across all areas. So if you have that flexible data architecture, you can do anything. There's a big change. A lot of people are moving to this Hadoop world. I mean, even at SAS, we store a lot of things in SAS data sets because we're SAS, right? But we are doing a lot of work with Hadoop now because it's cheap. You can buy a bunch of PCs, throw them together, put Hadoop on there, and it works. So once you have that architecture that allows you to do massive parallel grid computing, in-memory computing, in-database computing, you need to get all the data, and how do you manage that? That's probably the biggest challenge everyone has with big data right now. How do you get all the data together? And then how do you give it to people to use it? Where does it come from? It comes from lots of different sources. Once you got it, how do you determine that it's actually worthwhile for you to look at? I can take the sensor data, for example. If I am an oil refinery, I'm looking at sensor data. If a sensor keeps sending me the same value every second, I probably don't need to store that. Some of the techniques that some companies are looking into, including SAS, is to say, hey, with all this given data, how can I actually figure out what to store? So we're looking at algorithms to say, hey, given all the data, if the value is within a certain percentage, can we actually just store one row and say, hey, this data is relevant from this time period to this time period? That way I don't have to store a million rows of sensor data when the information is coming at the same rate. And then all we have to do is store when it changes. So that way you reduce the amount of data that you actually need to store, and you reduce the technology load that you need there. How do you manage the information once IT gets a hold of it? How do you get it to the users such that they know how to use it? Again, the whole EDW trick. EDWs are great, don't get me wrong. They reduce the redundancy, they give you one view of the data. But the problem is that if you're an end user and you get told, hit the EDW, and you have to do 7,000 joins, most business users aren't going to know how to do that. The technique when you get lots and lots of more data is that you have to now start to stream it. So think about the credit card companies. There's billions of people in the world. Let's just cut half of those out. Let's say 500 million people are using their credit cards every day. You know, swipe it for gas, swipe it for food, anything. That thing generates data. The credit card company has to take that data and within seconds figure out whether they should allow you to make that transaction or not. How do they do that? What they do is they stream the data. So they stream that transaction as fast as they can to the closest point, closest data center that they have. They then run analytics real time on that transaction to say, hey, is that transaction fraudulent? I use an example. A couple of my friends went on vacation in Nevada to a lake in the US. They went to a Walmart to buy some food because they were staying on a houseboat. All six of them went up. They bought $600 of food at Walmart because they were on a houseboat for 4 days. They went up to the credit card machine, swiped to try and pay, and it came back, and all six got rejected. Why? Because the credit card company said, their rules said, someone buying $600 of food at a Walmart outside of their home area, it's got to be a fraudulent transaction. That happened within seconds. This is the speed of stream, score, store, right? You might not need that fast transaction ability, but it does come into play if you're trying to do big statistics on there. So one of the things that we try and do is to say, hey, how can you stream into things like in-memory? how can you score that in memory, get that result back? How can you then report that to the enterprise? And then how do you translate that out into some type of operational reporting mechanism? That was just a slide to say, you know, once you've scored your information, you can get it out to multiple different ways there. How do you use real-time visualization to help you here? Well, with the whole analytical lifecycle, using that technological architecture, being able to use grid computing, lots of computers, using in-memory, information management, visualization in database. How do you get all that information together and make it usable? Let's talk about that. So, if you think about Facebook and, for example, or anyone online has big data centers. They have multiple places around different areas for redundancy. They have these racks of computers and they just have a bunch of software on there. What they're doing is they're storing all your information. So Facebook has a number of data centers around the world. They have these machines. Amazon's one of these ones that actually has semi-trailers for their cloud environment where they have machines in there and they actually have refrigerators and coolers and they just hook them up when needed. The idea about massively parallel processing, you're familiar with SAS. When you ran base SAS in SAS code and you executed a procedure, it ran on one process. If you ran a regression on, let's say, 1,000,000 rows, it might have taken you 2 hours. Imagine what I could do if I could split that process up into little chunks across thousands of computers. How fast could I get that result back, right? There's challenges in that because when you start splitting things up into small bits, lots of communication between the computers, but it's possible. So what Hadoop has done is they take all that data, spread it across thousands of machines, have the data redundancy, put it up in memory, and you can start processing it. For example, one of SAS's customers came to us from Singapore and said, hey, we have a credit risk problem. It takes us about 167 hours to run our credit risk model statistical analysis. That takes us too long. We need the answer within a day's window to make an effective judgment on whether or not we should be adding these products to our portfolios or not. They came up to us and they said, how can you make that faster? Well, our owner of the company, Dr. Jim Goodnight, a very smart guy, figures out the approximate number of transactions a single CPU could do, and then said, yeah, what you're getting is approximately right. You are hitting the limitation of a single CPU. We'll come back and see what happens. What we did was we figured out, using Hadoop as the data store, how to lift that data up into memory and how to process it across that whole memory grid, and we're able to take that 176 hours into 84 seconds, right? Now this was this specific area. The more machines you have to a certain point, the faster you get. The less machines is going to take a little bit longer. But imagine what you could do with those 165 hours. Let's just round it back and give 2 hours back. What could you have done in those 165 hours that you got back? Imagine how many times, how many different statistical models you could have ran in that time. How many different inferences you could come out, how many different optimization routines you can run by being able to split that out. I'll give you another example. We have an optimization product that looks at marketing campaigns, where if you have a budget of, take for example, $10 million, and you give it to your marketing department, and they can send out, if you're familiar with getting credit card offers, whether you get airline points, whether you get free trips or free presents there, that marketing department has to figure out with $10 million, what's the best use of that $10 million? Usually what happened, they ran an optimization routine. It took them 3 to 4 hours to set a baseline. They then went and ran a scenario on that optimization routine, and that's another 3 hours gone. They have to run multiple campaigns and optimize, not multiple, but tens of, I wouldn't say tens of hundreds, but at least 10 campaigns a day, if not about 1,000 a month. They have to figure out how to do that. How many times can you get the best bang from your buck from that? So from using high performance analytics and using the technological infrastructure here, they were able to now take those 4 to 6 hour routines and come back down into minutes. Now they can actually go through different campaigns, optimize them out, run multiple scenarios, and move on. So in the space it took them in probably a day to do one campaign, they can actually do 10 campaigns or more. So we've actually been able to give back their time for that. So how do we actually do it? As I said, I alluded to the fact that we can lift information up, put it into memory of disk, have some communication, a little animation happening here, and the results all get sent back to the user. So essentially, all we're doing is breaking up the problem into small chunks where possible. We're throwing it out on multiple computers or multiple CPUs to do the calculations. They come back real quickly, we put the results back. We're able to leverage that massive parallel processing here. So this is all fine if the data's all on the same environment. We have to have another option, because most of the time our customers have multiple databases. They have databases everywhere. So what we've done is the ability to actually very quickly parallel load data across into memory on a different set of what we call compute blades. Main reason why you want to do that is because when you're doing these big Hadoop data stores, most of the time you're running a lot of your data management tasks on there. So you're writing out to disk, you're consuming those resources. If you add your analytical processes on top of those, you start dragging the machine down. Some companies say, hey, our Hadoop infrastructure, our technology infrastructure isn't being utilized that well. We want you to put your software stack on top of that and utilize those machines. And we say, sure, but we can't guarantee the same performance if it was pulled off. So the alternative is to say, hey, if you already have heavily taxed machines, set up another set of cheap machines that we can load the data in parallel into memory really quickly and then do the execution of that and come out. And this helps us because when you have, as we said, if your data is not all in one place, you can pull the data from parallel very quickly from Hadoop, from Oracle, from DB2, from Excel stores, and you can process that extremely quickly. So now what this means is that instead of looking at 1 million rows of data and doing a statistical model and sampling on that, you don't have to sample anymore. You can run your models on your billions of rows of data and be able to get your results back and see very quickly whether or not your champion challenger model actually works, which one comes out. So, you know, this is a great technology there. We're using technology to do the same thing that we ordinarily did, but it took us hours or minutes. Now we're getting it down into seconds. So instead of having to sample the data, we can do it all on the big data that comes in there. So the last bit is the collaboration approaches to line to business. And I'm just walking back just to check time here, which we're doing pretty good from. When you get those results, it's all about how do you get them out? How do you get the value from the big data? You know it's out there. And you guys all know, I'm preaching to the choir, you guys are all very strong in statistics or know about statistics. You know what it means to add statistics to the data to get the value out. But where we come in is we help you with a big data challenge. We help you apply high performance analytics. And the reason why we call it high performance is because you got to put it across lots of compute nodes to get the speed out. How do you actually get that data out? The biggest challenges come across as usual. The same things never change. Getting your data, getting clean data, getting the right data. It doesn't matter whether you have a small amount or you have a huge amount. If your data is bad, your analytical results are going to be bad, your reports are going to be bad. The same problems are still there for small data as they are for big data. But hopefully by using analytics, you can weed out some of that information. And then the rest goes through access to the right data, information silos, data being stored by certain people, not being shared by others, getting it all together. How do you make that come out? So another example of taking a single process, spreading it out, how you can increase by running multiple models the lift rate from there. But let's get into some business cases here. We have an insurance company and they have lots of emergency medical records. So just some examples of how they're using big data. They had a huge data explosion. They didn't know what to do with it. They had a lot of unstructured data. They need to improve the quality of healthcare here. They used SAS high performance technology there, and they used a Greenplum computing environment in this case, and they reduced their modeling time. So just reducing the time alone of doing this stuff is key. Just think about it. If we could give you back 30 minutes, 1 hour, 2 hours of your day, what would it mean to you? Could you do more? That's what the high performance analytics is doing. This one here, reduced modeling processing time from 4 hours to 10 seconds, right? Seems like something out of a science fiction movie that you've seen there. Reduced misclassification rate. Increased lift. I have another example. The Australian Institute of Health and Welfare, government employee, government institution over there, they use data exploration to harness and increase the available data following recent accreditation to sensitive data information. That whole high volume of complex data, they started with the visualization piece. How do we understand all this data before we start applying the statistical analysis to it? They used a solution, SAS Visual Analytics, which uses high performance analytics again, to get the information that they need into reports out to the right people, so to make decisions faster here. Another government organization, Hong Kong Efficiency Unit, sounds a little bit funny, but basically they get tons of emails and calls regarding services and suggestions and complaints based on the services that they give out. They're a healthcare service area there. They used a lot of two different technologies, the analysis and the text mining, because the text mining does the unstructured into the structured, and they're able to analyze tons of actual information and be able to print out reports to a lot of their different constituents that needed the information quicker and faster. They're also able to find new relationships in the data that they didn't know. So they brought in the unstructured data by searching the survey results or comments that came back. Another human services agency here, ever tightening. You probably guys know, budgets are getting tighter, data gets bigger. How can we utilize the technology to uncover insights faster? How do we get the information out there to the right people, right time? There. And this last one was a real interesting one, actually. The Danish National Board of Social Services, they actually had a mandate in August 2013. They needed to get information out to other government agencies by that time. They were focused so much on the data acquisition part that by May of 2013, this year, they hadn't got anything out to their people, to the masses yet. Lucky for us, they asked us in and we helped them out with a solution. Within 2 months, they have an actual website that you can go out to today and look at the Danish health data, and you can actually download it and other people can use that data for them. They're actually trying to expand what they actually currently do with that data and for other people to use that information there. So big data is something that means a lot for different areas. Of course, it wouldn't be remiss of me not to say that, of course, SAS plays a lot in the big data area, and we are the leader for that. But in conclusion, just some food for thought. Here, big data represents your opportunity to enhance potentially market leadership if you are a commercial company. But are you leveraging all your data assets? Are there different ways that you can look at your data? Can you find that needle in the haystack? Think about sensor data. How do you know when to replace a part of an oil well before it breaks, so that you don't lose, so the oil companies don't lose hundreds of millions of dollars because the oil well is down? It's just an example. How can the analytical lifecycle, which is just SAS's way to talk about how you actually get meaning out of big data, how can that help you out? It's a methodology. But think about, how do you go through your current processes today? Can you make them better? Can you use high performance analytics? Can you use some of these technologies? Can you add unstructured data to find better meaning out of what you currently have? Are there other sources there? Are you planning to modernize? Because if you're running today on a single machine, can you use multiple CPUs? Can you use multiple machines to get your answers faster, get your results back quicker time, give you back that time from there? How can you align business and IT? Because you can't do it yourself. Business user can't acquire a stack of machines and run them. IT normally does that, so you need IT's help. How can you get IT on the side such that they can provide you the hardware infrastructure such that you can do the high performance analytics that you need? So with that said, I think we are pretty much on time, and we'll open it up for questions.
Well, Justin, thanks so much for being so accurate in your timing. ¿Hay preguntas? ¿Alguien tiene algún comentario, alguna sugerencia? Ya hay traductor, ya él tiene con qué escuchar la pregunta si la quieren hacer en español o por supuesto la pueden hacer en inglés. A ver, Memo.
Justin, in one of your slides, you have one part you have the data scientist, and in another one you have the statistician. As I look like there is a really big difference between a statistician and a data scientist. In your opinion, give me 3 real differences and 3 similarities between those two persons.
That's a very good question, because there is a blurring of the lines between the data scientist persona and the statistician here. I would say, and I'm trying to get to the slide as we get there, the data scientist is someone who actually knows probably the database and SQL and how to access the data extremely well. That'll probably be the predominant factor of what I would say a data scientist is, while your statistician understands a lot more of the underlying models, how to apply statistics to the data problem. The data scientist is the person just getting into that. They know a little bit enough to, I would say, be dangerous or use a, it's like, I use an analogy, it's like when you learn something, you start off at a very beginning area and you start to progress from being a beginner to an intermediate to an advanced person. The statistician is your advanced person in analytics. Your data scientist is your, somewhere, they're not a beginner, but they're an intermediate area of knowledge of statistics. So they're trying to use their knowledge of statistics and data to try and get value out of that. In some companies, data scientist is the new statistician. It's just a label. It's just a name so that people can get a job and say, hey, I'm a data scientist, you need to pay me more money than the guy that gets the data for you, like the data warehouse guy, honestly, at the end of the day, because if you guys can access data and you can run analytics on it and you know how to do it, you are a data scientist and you are a statistician. So I think, you know, at the end, putting labels on it, I don't think there are 3 things that could categorize a data scientist, yet you could say a statistician is a data scientist at heart as well, because majority of the statisticians have to know how to get to the data before they could even do the analysis.
¿Alguien más? Veo. Bien.
2 words come to my mind on hearing you. First one is scary. I don't know whether you belong to WikiLeaks and similar things, because that's being able to do this type of analysis, as you just explained with your case studies, is a bit scary. Big Brother watching all over us and on real time being able to pinpoint and put his finger on top of your head. That's first thought. Second thought on the explanation of your approach is translated in my mind into common sense. Way old-fashioned common sense. Split a task into smaller tasks and then put it all together. And just to throw up another example of the type of big data management on real life problems, take any major communications company, telephone, whatever. You make a call from Mexico, Aguascalientes, to your office, and then invoice all the different providers that are part of that communication in real time, so that you get the money that you need to pay in England, in Japan, in US, in Mexico, because of the tiny parts of a second on which the communication traveled through those different providers. That's a major big data problem, and happy to say it once was solved here in Mexico. Thank you.
No, absolutely, and great comments. And you know, to the scary comment, there is a organization that I can't name that looks at a lot of data for threats to that country, and they analyze those threats, and they look for patterns when it happens again, such they can act on them. And they're looking at lots and lots of data. And I'm sure you can imagine who it is, but you're right, it is scary because it gives the opportunity now to look at things where ordinarily you didn't think they were looking at. So Big Brother is looking. To the common sense point, absolutely. One of the things that, you know, SAS has tried to do, if you're familiar with using SAS procedures, is that to help everyone go from the single-threaded or the single machine approach to how to split it up is for some of the procedures that we could actually, what we call multi-thread or split across multiple processes, all we did was add, it's a new proc, but or just add HP on the front. So we have these procs called proc HP, mining, proc, etc. You use the same proc as you did before, but if you have the high performance environment, you add HP on the front, and it can now utilize that massively parallel processing approach. So you're correct. It is simple, it is common sense, but there's also some actual statistical approaches that don't lend itself well to the actual splitting of the component out. And one of them that we've noticed is forecasting. Forecasting, usually you have your data and you aggregate it up. When you aggregate it to the level that you want to forecast off, that's usually a small bunch of data, but you could be having, you know, data at the seconds level, and you want to aggregate it up to the minutes and then forecast off the minutes. Once you get it to the minute level, you usually don't look at it forecast out for the hours. So that amount of data is very small, so it doesn't really lend itself well to being spread across multiple processes. The aggregation bit does, but the actual forecast bit can be done because usually you're dealing with like 200, 300 points. You can do that on one CPU extremely quickly. So during SAS's research, there are some statistical analyses that lend itself well to the multi-threaded approach, and there's some others that don't. So just be aware of that, but appreciate the comments. Thank you.
¿Alguna otra pregunta? ¿Alguna otra? Well, I may have one, if I may.
Yes, absolutely.
Since we have a lot of young people around, what would you suggest they major in, they study? Mostly statistics, ITE, computer science. What would you suggest?
I would, if I was to do it again, because I am older than what I actually look, but if I was to do it again, I did a computing science background. I use zero of that computing science background pretty much now. If I had my choice again, and I did my master's in internet technology, so how to hook up routers to talk to each other. If I was to do it again, I would actually jump into to do either a master's of statistics or something in a deeper level of statistical analysis, because there is an actual glut in the workforce area of statisticians that know how to answer problems and questions. Every customer that comes into our briefing center in Carey asks us, how do we get people in our organizations that understand what analytical techniques to apply? And we say, you have to hire them. You need to go. There are a couple of universities, and hopefully there's some universities here that want to talk to potentially SAS, only in terms of we can help you figure out what curriculum there are. SAS was founded from NC State, and there is a advanced, I wouldn't even call it advanced, it's a Masters of Analytics program there that SAS has helped put together so people can do and learn from a business perspective how to apply statistics to business. And another university, University of Charlotte, has picked up, they call it a Masters of Science, but it's actually in statistical analysis as well, or business analytics. They're calling it Masters of Business Analytics. So they are trying to figure out how they see there's a glut in the resource market out there for, you know, good statisticians to answer this. If I had my choice, I'll go back and do that, and I'd call myself a data scientist, because data scientists now commanding a lot of money, and using that background, I'd be able to, you know, answer quite sophisticated business questions for there. So I am not a math person. I'm good at math, but I'm not a math person at heart. But knowing what I know about the direction and the future of where things are going, there is a big need. And I'll give you an example. Probably in North Carolina, in SAS's headquarters, we probably have the highest PhD statistician per capita in all of the US. Why? Because SAS hires these people to program for us the statistics. It's just something that we do. In those R&D departments, everyone there has a PhD and is a recognized statistician, except for the junior people that we hire straight out of college. But all those guys and girls that are coming out of college, they're getting their masters and working towards their PhDs in statistics. Now, don't get me wrong, I'm not saying SAS is trying to hire them all so none of you guys can get them, but I think there's big opportunities for the universities to actually build curriculum to build up those areas. Of course, you know, businesses, I would say right now, financial services, even government agencies, retail, telecommunications, and the oil industry all require statisticians to do the analysis that they want to do today. If you are a statistician but you don't know how to access the data, go to a computing course, learn a little bit about databases, learn a little bit about that, become that data scientist, right? Get that extra knowledge, because it's gonna help you. So if I was a young person, I would definitely, if I was to do it again, I wouldn't quite do, I wouldn't get my PhD in statistics, I don't think, but I'll definitely probably do a nice mix of some type of IT, business, and then do some type of master's course in business analytics, so that I could help any customer or, potential work area that I was to go into.
Thank you so much.
Anything else?
¿Alguien más? Well then, will you please join me in thanking Justin for his presentation?